So in the final in the previous video, we basically go to the final check. So in the final check, we need to see for a verification about the anode current capacity, and then do inequality and try to see if the current capacity, basically this section, we have one anode, if this current capacity is larger or equal than the average current and time. If that's the case, then we can set that we have a anode that can protect the structure for 20 years. So we see here that the average is 15.2, that if you allow me to go back, it's basically the maintenance parameter in the corresponding current demand. So this is 1.52, so it's the maintenance value, which is basically called the average value. This is now, and then we can say that yes, the anode can be basically protect for 20 years. Now, we don't know how long the anode will remain on the active life of the anode, so we need to calculate the active life of the anode. And there is a formula that is reported in this standard BSEN 13174/2001. That's basically the life of the anode, and it should be calculated. This current, this equation could be minimized or could be reduced to the definition of the current, which is the delta E, or the potential, driving potential over the resistance. This utilization factor, electrochemical efficiency, time in hours, and the electrical hours in a year, and the current output. This formula, the second formula, this is basically implies that the average current output is the current at midlife. It's basically the 85% over 2, which is 42% of weight. One way to solve, and that's basically at this moment is the question that we need to have. One way to solve is the resistance equation shall be calculated for different percentage of the solution or the utilization, and take the average value. For example, if we have 37 and 47, we need to go to the Dwight equation, to the resistance equation, calculate for 37 utilization, for 47 utilization, take the average, and compute the current. Isn't it? So I will go up on the slides, and basically this length and this radius should be calculated with L final, with the utilization of 47 and utilization of 37, or the numbers that you want, something that you want, because you need to take the average, the same from the radius, and then you compute the resistance for both, take an average value, come here, come to this, and compute the current. So you put the current in the life, and you will basically determine the life there. What is the life of the anode? And the question, basically the task, is your engineering thinking. What is the anode life? That's the first question. You need to answer that. And is this enough to protect the structure for 20 years? Do we need to have one anode, or we need to have two anodes to protect the structure? If need, provide an engineering recommendation. So basically you need to say if this is good because we are whatever of, we need something else, or whatever information you want to put. Once you add these questions, basically the task is solved. Write all the numbers in the equations, and at the end, that's exactly the question you need to answer. This question needs to come by Thursday. So I need to have it on Thursday to grade you and to have the final grades for you. I will do another videos for corrosion inhibition and types of corrosion, and then we basically will close the course. So corrosion inhibition will be very quick because it will be just chemical inhibitors, and then we have the types of corrosion, and we grab basically all the course. Okay, thanks.